All right, in today's episode, we're going to be changing out this little compressor here on this little Heatcraft unit. There's our replacement compressor. I hope you can hear the Christmas church bells in the background. So yeah, anyway, this is what I would consider a budget job. The customer, I believe, is looking to replace this equipment once it becomes more readily available, but in the meantime, we just need to get it up and going ASAP. One of the technicians last night came out and diagnosed this. So yeah, we're just gonna go ahead and start cutting this thing out, or rather sweating it out. And then one of the other things I'm gonna do is I'm gonna cut the dome off this compressor once we're all wrapped up here and see what actually killed this compressor. Judging by the discoloration on this side right here, I'm assuming we had a fair amount of flood back at some point in time for an extended period of time. Not real sure. A couple areas of concern are a little bit of oil on a liquid line, but that could have just been from the previous technician removing his gauges. Now, if this was a permanent repair, what I would do, because I don't like these valves, they tend to leak. I normally cut those out and I straight pipe it through here with just a little service port or a new valve. I do the same on both of those. I would replace my sight glass along with the filter dryer. Even though the sight glass is fine, it's just something I like to replace if I'm doing the dryer as well. Also, that compressor isolation valve right back there with all the dirt on it, I would normally cut that out and just straight pipe that as well, just to prevent future leaks. And then I don't mind these pressure switches, but I would probably put in a mechanical one just so I can adjust it if need be. Condensing fan motor doesn't seem bound up. Whenever I do a compressor, though, I generally do a condensing fan motor just to be safe, because there's no point in putting a $1,000 compressor behind a $200 condensing fan motor that could fail. We'll do our contactor, of course, new start components. But like I said, guys, this is just a budget job. We're not getting too crazy with it. Customer doesn't want to spend a whole heck of a lot of money on it, so we'll be recovering the refrigerant. I'm going to test it for acid, and then we will be reusing it. I got my recovery tank over there. I'm going to pull a vacuum on it and get it ready. Down to 700 microns on a recovery tank. I like to keep the vacuum on there till the sides cave in my recovery tank. Then I know it's good. In the meantime, I'm going to do a quick little acid check on this system, just to make sure there's no acids or anything in there. Now, ideally, I'd like to do this when the system is running, but I don't have that pleasure. Just a quick little spritz on there. I don't know how well this is coming across on camera, but it doesn't seem to be any signs of inorganic compounds such as acid, so we're good to reuse this refrigerant. Again, guys, budget repair. System will be eventually replaced, so I'm not too concerned about it. All right, so let's get to work. Real quick, guys, on a side note, I don't have access to this walk-in cooler right now because the building is closed. So I don't know if my evaporator is running or not. Sounds like it is through this wall, but that could also be the walk-in freezer evaporator that I'm hearing. But anyway, we'll be pulling through both sides. Once we actually do pull a vacuum, right now I'm just going to recover everything. And again, I will be recovering from both sides. It'll be a little bit a slower process, not ideal, because we'll be pulling through that TXV and recovering into this tank, of course. But again, guys, real world situation. It's not ideal, but sometimes this is what we got to deal with. So right now, got my machine hooked up. This is kind of loose. I'm just going to purge a little bit of refrigerant through here. Make sure we got all the air out of the lines. And then, yeah, we'll go ahead and set this to 0. And see how much we recover. Compressor's unwired. We're pretty much ready to yank it out of there. I got my low side pressure switch taken off right there, just to make sure I don't melt it. I cut the dryer out because I really prefer to cut them out whenever possible. Now, I mean, I do have to unsweat the little stubbies that I left on there, but that's all right. I can deal with that. We just got to come back here. I think I'm just going to wrap this line to protect the high side pressure switch and unbraze that side. Then we'll pull it out, throw the new one in there, flow some nitrogen. That's all ready to go. And then we'll braze the new stuff in place. So we're all brazed up in place here. Everything looks good. My joints all look pretty good. Got to get my heat blocking putty off my dryer. I'll clean that up a little bit. This putty works pretty good. Keeps your dryer from turning all black and catching fire and whatnot. Yeah, the suction side looks good, looks good. All right, let's pressurize it and make sure we don't have any leaks. Well, we passed the decay test. Just pulling a vacuum on this. I know it's not the best setup for the vacuum tree, but it is what it is at this moment. I need to get a new set of gauges, by the way. But yeah, so we're down to about 800 microns. Doing good. I'm gonna take this guy home, back to my shop, pop the dome off, pull the motor out, and see what we can see inside of that thing. Quick little truck tour, you guys. Just got this van, so it's still kind of shiny, kind of nice and neat and organized. You know, got everything just about where I want it. Just threw my winter gear in the truck here, so yeah, we're good to go for the winter time, bud. This is one of those unicorn jobs where you get to pull your truck up right next to the condenser. I mean, it doesn't get any easier than that. Flipping awesome, eh? We're up and running. We're pulling about 3.5 amps, 3.6 amps. Using my fancy dancy, is that a word? Anyway, using my Emerson mobile app, I scanned this, and I found the working amps for about 110 degrees. Now right now it's like 45 degrees outside, so my amps are a little bit lower, I'm assuming because of that. But yeah, so that looks good. I'm happy with that. I don't know if you guys can see it, but our sight glass is full. A little cloudy because it's old and crappy. But yeah, satisfied with that. Got a 40 degree evaporator. About a 95 degree condensing temperature. We do have a headmaster on this one. Bypass valve. Does appear to be bypassing, so we're all good. Now, for any of my keen-eyed viewers out there, they'll notice that the walk-in freezer disconnect is off. I just spoke to the owner, and she says that's never worked. They would like to get it up and running, so I'll cross my fingers. We'll get to dive into another project. Now that one, if I get to touch that one, that one's getting the big picture diagnosis. Did have to add a splash of refrigerant to it, a little over 10 ounces. Nothing too crazy, but I'm gonna wrap this guy up and head on the inside and see what our evaporator situation's like. Now, I didn't get footage of this earlier, but we were at 70 when I got here. We're at about 45 now. There's our evap. Yeah. That evap's pretty much shot. Whole system just needs to be replaced and done with. Check out this non-working freezer. Spooky. Climate control, everything is turned off. Evap coil looks better than the other one. Now, she said this system hasn't ran in 5 years. I mean, that's how long she's been here, so maybe it ran before that, maybe not, nobody knows. What is this thing? Raychem. Must be, oh, looks like it's some sort of heat tape. That's weird. Oh, that's the heat tape I saw on the drain outside. There's some heat tape running next to the drain. It's not wrapped around it or insulated whatsoever. It's just running next to it, which isn't going to be sufficient in the wintertime, but it's a good looking box. You know, everything looks nice and new and clean. Floor's not warped. Yeah, this would be worthwhile to get up and running for them. Then if they ever did have cooler issues, they could just pop the door open in an emergency and get them by for a little bit, and they wouldn't lose all the product, I suppose, like they did this last time. As you can tell from that last clip, the cooler's down to about 45. It's going to take another couple hours, in my opinion, to get down to 35, 38 degrees. So I advise the customer just to keep all the product out of there. They do have another cooler, which actually I was trying to get some footage of it, but they have another cooler that's all wood because this building was built in like 1850 or something ridiculous, but it's a super cool looking cooler. And all their food is in there, so it's at temperature. I just told her just to give it a little while. I'm not familiar with this system, so I know we just changed a compressor in it, but if there's any additional bugs that need to be worked out, which I didn't see any signs of, I would rather have it happen with no product in there than with a cooler full of product. I don't want them to lose any more product than they already have. But yeah, we're all set here, guys. And like I said, I know this job wasn't pretty. It wasn't textbook. There was a couple things I would have really liked to do, but it's not a big picture job. All right. HVACR videos. By the way, if you'll notice my fancy dancy merchandise here, go check out my buddy Chris Stevens over at HVACR videos. Click on any one of his videos, scroll down. There's a link to his merch store. You can get super cool merch just like this. All right. But for now, anyway, like I was saying, actually, let's get back to what I was saying. It's definitely not a big picture sort of repair, if you will. Like I said, there's a couple things I wanted to do or would have liked to done, but it's not in the budget. Looks like this equipment is going to be replaced soon, so there's no point in going through and doing all the other stuff that I'd like to do to prevent future issues as far as replacing valves, straight piping stuff, repiping this and that. There's just no point in doing it right now. So it is what it is, guys. Real world stuff sometimes. So be safe out there. We'll see you on the next one, all right? Here's a compressor from earlier today that we pulled out of that walk-in cooler. And what had happened was it seems to be physically seized up. Drawing locked rotor amps, it won't pump, tripping off on the overload. So what we're going to do is we are going to cut the top off this thing, pull the motor out, and see if we can figure out why it died, all right? So let's get to work. You can see our motor itself is mounted to some springs. We have our suction line right here, which we need to cut out of the way. All right, just a pair of alignments, cutters right there. Probably fight me a little bit because electrically we're still hooked up over here at our terminals, but we'll see if we can pop this thing out. All right. Yeah, oil looks Looks black, looks old. Smells pretty awful. Yeah, that's some strong smelling oil there, guys. Let's get this out of the way. Get our cutting tool out of the way. Yep. That's pretty well seized up. First thing I'm going to do is change my gloves, and then we're going to pull the stator off. All right, there's our stator. Looks all right. I don't see any damage. Nothing seems to be burnt out on it. Looks like it would function. Right here is our rotor, obviously. See if we can get this out of here. Now this right here, let's see, what exactly would this be? Because this is going to be on our discharge side. It wouldn't make sense to be on our discharge side because it's got a port right here. I'm guessing that this would be some sort of internal accumulator, possibly. I'm going to set that aside and do some homework on it. Some sort of weird, mysterious little port right there. Don't worry, guys. My Milwaukee's in my work van. All right. Get these pesky little screws out of here. All right. Well, look at there. That's pretty fun. Now, that's definitely not supposed to be there. Now we just gotta figure out what the hell that is. So it's stuck in there. It definitely got smashed. Looked like it went right over here, right? These are obviously our reed valves right here that fit like so. And so this, oh yeah, there's our other one. So it would fit like this, right guys? And these little broken pieces, which I'm gonna dig out in a second, looks like one went across here and then the other would go across here. So these would be our, let's see, as it's sucking in, these would go down. So these would be our suction reeds. And then it would compress and push out these side reeds. Maybe. Let's, yeah, it would have to. So it would have to suck in, pull these down, and then push out that away. Let's see. Let's separate this plate here. Yeah, so it was our discharge reeds have come apart. Interesting. So if you remember, guys, from that video, let's just put this right down here for a second. So yeah, if you remember, one of the things I noticed on the head of this compressor, on the top of it right here, and I could be wrong, but there's obvious discoloration right here, which I thought maybe was due to liquid floodback, which could definitely be our case, why our discharge reeds have shattered. What do you guys think? Get a close up there. Very nice. Yeah, she definitely got smashed. She got smashed pretty good. Now, I wonder if we can get this to turn. Yeah, she doesn't really want to come out of there. Oh, that's why, because it physically can't come out of there because of the wrist pin on the bottom. Gotcha. So we would have to remove our, looks like we got to move our rotor. All right, well, let's remove the rotor then. All right, guys, I gave up on trying to get our rotor separated off the shaft so I could physically pull this piston out and look at it. What we can do is we can just push the cylinder down and we can get a pretty good bird's eye view of the inner cylinder walls. Yeah, I don't see any damage whatsoever. All the damage seems to be just on the head of this piston right there. So the other thing that you'll notice, the top of this piston is black, which I don't know enough about this particular manufacturer's compressor, but looking at the sides of this, piston are you know, a regular gray metal. So I'm assuming that the top of this has experienced some sort of high temperatures, burn or whatnot. So I wonder, I don't feel like any sort of high temperature, like if we had loss of lubrication or say the condenser was dirty, I don't feel like that would have caused such damage in our plate, in our discharge reed, our discharge valve plate here. I'm pretty sure that we got into some sort of liquid pumping situation, and it obviously couldn't deal with it anymore, so it blew itself apart. That's what I think. Now let me know what you guys think. Go ahead and put some comments below here. Send me an email if you want. CuriousHVACguy@gmail.com. But that's all for today, guys. Thanks for watching.